All right, let's talk about something that's quietly turning our powerful AI models into absolute super geniuses. It's called Retrieval Augmented Generation, or just RAG for short. And trust me, this isn't just another small upgrade. It's a complete game changer in how AI finds information and gives us answers. So let's dive in and see how it works.
So here's the game plan. We're going to start by looking at the 3 huge blind spots that every standard large language model has. Then we'll check out the first attempt to fix them, something called fine-tuning. After that, we bring in the hero of our story, RAG, and we'll get into the nitty-gritty of how it actually works. We'll even put RAG and fine-tuning head-to-head. And finally, we'll see why this whole approach changes, well, pretty much everything.
Okay, so let's start with the problem itself. These large language models, or LLMs, they're brilliant, right? But they also have some really serious, critical flaws.
You've totally been there, right? You ask an AI a question, and it gives you this beautifully written, super confident answer that is completely and utterly wrong. It's a huge problem, and to get why it even happens, we gotta pop the hood and see how these things actually store their knowledge. You see, everything a normal LLM knows is basically memorized and burned into its internal wiring, what we call its parameters. This is its parametric knowledge. It's kind of like a student who memorized thousands of textbooks for a final exam, but isn't allowed to look at any new books or notes once the test begins. And that leads to some major issues. So this memory-only system creates 3 massive problems. First, the LLM has zero clue about your private stuff, your company's internal documents, your personal notes, because, it never saw them during training. Second, its knowledge is basically frozen in time. It doesn't know what happened yesterday, let alone 5 minutes ago. And third, and this is the big one, it can hallucinate. Because it's just predicting the next most likely word, it can confidently just make stuff up when it doesn't actually know the answer.
So, naturally, people tried to solve these problems. And the first big idea was a process called fine-tuning. It's a really powerful concept, but as you're about to see, it's also, it's pretty clumsy and incredibly expensive.
Here's a good way to think about it. Fine-tuning is like taking a brilliant, knows a lot about everything model and then sending it to a super intense, specialized bootcamp to learn one new, very specific subject. Yeah, it works. The model learns the new information, but man, it is a huge amount of effort every single time you need to teach it something new.
And that leads us straight to the downsides. Fine-tuning costs an absolute fortune in computer power. You need a whole team of specialized AI engineers just to pull it off. And maybe the worst part? The second your data changes, a new product gets released, a new fact is discovered, you have to do the entire expensive, time-consuming retraining process all over again. It's just not built for a world where information changes fast.
Okay, so if fine-tuning is the brute force way of doing things, RAG is the elegant, clever solution. Honestly, this is the superpower we've been looking for.
To put it simply, RAG gives the language model the exact information it needs right at the moment it needs it. So instead of trying to cram new facts into the model's brain permanently, RAG just hands it the relevant documents as context for every single question.
And the difference is just night and day. Fine-tuning is like forcing a student to memorize a whole new library for a closed book exam. It's stressful, it's inefficient. RAG, on the other hand, is like giving that same student an open book test, but it's even better. You're not just giving them the book, you're handing them the exact page with the answer on it. It's just so much smarter.
So that all sounds amazing, but how does RAG actually pull it off? How does it find that right page of information so quickly? Well, it's a pretty cool 4-step journey from your question to the final answer.
The whole thing breaks down into these 4 key stages. You've got indexing, retrieval, augmentation, and finally, generation. That first step, indexing, is something you only have to do once. The other 3, they happen in a flash, every single time you ask a question.
Okay, step 1 is indexing. This is the prep work. You take all your documents, your PDFs, your meeting notes, whatever, and you break them up into smaller, bite-sized chunks. Then a cool piece of AI converts the meaning of each chunk into a string of numbers called a vector. You can think of it like a unique numerical fingerprint for that piece of text. All these fingerprints then get stored in a special kind of library called a vector database that's built for super fast searching.
Next up, retrieval. Now this is where the magic really kicks in. When you ask your question also gets turned into one of those numerical fingerprints. The system then instantly searches the entire vector database to find the chunks of text whose fingerprints are the most mathematically similar to your question's fingerprint. So it's not searching for keywords, it's searching for meaning.
Step 3 is augmentation, and it's super simple. The system just takes your original question and basically copy-pastes the relevant text it just found right into the prompt. So now you have this new supercharged prompt that has both your question and the exact information needed to answer it.
And finally, we have generation. This new, beefed-up prompt gets sent to the large language model. But now, the model doesn't have to guess or try to remember something from its old training data. The facts are sitting right there in the prompt. This allows it to generate an answer that is way more accurate, relevant, and actually grounded in the facts you just gave it.
So now that we get how both of these methods work, let's put them side by side. This is where you can really see why RAG is such a massive leap forward. The biggest difference philosophically is this. Fine-tuning is about permanently changing the model's brain through that expensive retraining. RAG doesn't touch the model at all. It just provides it with external knowledge on the fly as it needs it. It's the difference between performing brain surgery and just handing someone a cheat sheet for a test.
And this gives us a really clear guide on when to use what. Look, you might still use fine-tuning if you want to fundamentally change a model's behavior or its personality. But for pretty much everything else, if you're working with your own private data, if you need up-to-the-minute information, if you need to fight hallucinations, or if your data is constantly changing, RAG is the clear winner. It's cheaper, it's faster, and it's just way more flexible. So let's bring this all home. RAG isn't just another cool technique. It is a direct solution to some of the most fundamental problems that have been holding back AI for years.
I mean, just look at the report card. That problem of accessing your private data? Solved. Just add it to the RAG system. The problem of having outdated knowledge? Solved. Just drop in the new documents. And those really annoying hallucinations? By giving the model facts to work with, RAG all but eliminates them. It's a clean sweep.
And if you need one stat to blow your mind, it's this. Remember that whole expensive, time-consuming retraining process for fine-tuning? The time it takes to update the AI's knowledge with RAG is 0. 0 hours. You don't retrain anything. You just add a new file to your database, and boom, it's instantly part of the AI's knowledge base.
And that kind of leaves us with one final big thought. For a long time, we've been held back by what our AI models could remember. But now, with RAG, we've basically given them a library card to, well, everything. They can access and reason over almost any information, instantly and accurately. So the barrier isn't the AI's knowledge anymore, the barrier is the quality of our questions. So what are you going to ask?